Tutor Secure Architecture. I'm Kawin here. My student number is MS2091105 ETCS Assignment 5 MSc Cybersecurity. Today's agenda. From the beginning that I just brief about the objectives of the presentation. Later on, then DevSecOps security fundamentals briefly discussed, and develop DevSecOps principles, security architecture, security tutor architecture. That based on that, my today's presentation is a Twitter. That how the Twitter applications is implemented according to the primitives of the security and the DevSecOps architecture or the requirements and such principles that apply to this, especially for the Twitter application. Conceptual architecture, security risks in given architecture for the DevOps, DevSecOps, and Kubernetes. That's the foundations of fundamentals initiatives that we need to study, means to learn and should know about ultimate goal of this presentation. So again, just when you think about, when you know about like architectures, that why especially that the main requirements of the architectures, that what we expected from the applications or software or development life cycles, those stuff, that technicals, why with the requirements, that is the major questions and challenging questions from asked from us. That the answer of this, that we expected that agility and security based on development life cycle. So that is the main object, because that most of times when you're comparing the last 2 decades, there are plenty of methodologies. For example, like some development process are there, the waterfall software development process approaches, like such, there are plenty of applications. Then what that lack of them is we not mainly identified in particularly the each and every segments covered by the security, ultimately agility of the software, but it will be well dragging for a long time. Sometimes customer may not happy and not expectations to become a reality within the small period of time. So that is the challenge. That overcome this challenge is now we have some sort of a exact framework. It's developed to carry on and overcome those the drawbacks in this, particularly for development process. So that is why DevSecOps, development security operations framework, are the popular among the developers and these days. Not only that, there are plenty of things we'll discuss for the latter part of this presentation. So agility is the main and security is the main. That is the main things that we are discussing. So as mentioned here, that the legacy software development practices given a huge impact of the agility of the development along with the security vulnerabilities and other stuff. Exactly. So because if that is not the legacy systems software development process, what happened, so it may have more possibilities of sort of a vulnerabilities due to the lagging and as well as the lack of the security concerns each and every areas. So that's why that we need to discuss it further. Get rid of the traditional practices. However, legacy we need to minimize that. Of course, like we need to ignore, eliminate from our development process for the nature of our future so development. Instead, many security, well, due to that, many security vulnerabilities. Not only that, there are plenty of effectiveness being directly and indirectly affected to the systems. Security is a part of the system development life cycle nowadays, not the previously. The security is the main part. Security, we can't ignore the security while we are considering the development process. So, and it is the main part of that one. And then then covered that entire life cycles along with internal and external factors. But not only the internal factors, external, internal, both factors to be considering, and the security. That's why DevSecOps is industrial best practices and the culture of software engineering along with the proper framework. That aim of main three scopes: developments, security, and operations. There are three major parts on this one. So the conceptually DevOps is dedicated to automated, monitor, and apply security in and segments of the software development process. Due to the security concerns that, and not only that, the automate is the most reliable solution to provide for the developers, because exactly the manual process is may hard, may dragging, may that we need to get rid of the dragness. So automation is the autopilot is the most suitable solutions. And continuous monitoring, it's not only one place, 24 hours, 24/7 monitoring skills. So both together, then hopefully we can have the that is the dedication of the DevSecOps development process and the framework. Continuous integration and continuous delivery, that is a major important factor to be concentrate. CI/CD are the major characteristics. A mission critical on DevOps functionality. And there are some other the interrelated DevOps characteristics, such as the plan, develop, build, test, release, delivery, deploy, operate, and monitor. So the major and main crucial and critical characteristics that's considered on this DevSecOps. Just to brief some definitions is on theoretical the DevOps is DevOps applications of software development methodologies to infrastructure operations. It's mainly that is infrastructure concern. DevSecOps, the integration of continuous security. Continuous is highlighted and underline the security principles, process and technologies in DevOps culture, practices and workflows. It is under circumstances of the principles, that principles should be obeyed while developing the process, and the process are very keen and the perfect. Plenty of new technologies are being used in this one and then practices. That's why this all together DevSecOps systems framework will be applied. There are the methodologies. This is a kinds of a framework I just already mentioned, and this is not only the one process. This is a amalgamate of several segments. Ultimately, it's in working as a one team. So that is the successfulness of this framework in rather. So information security management through reflexive security is a new latest phenomena on concepts to deploy for the applications. The dynamic, interactive, holistic, and effective way of approaching the development process. So in here that DevSecOps, DevOpsEx, and DevSecDevOps. The three concepts, it's equivalent, sometimes may having some different practices, different principles, all amalgamate together. So ultimate results is the more accuracy, more reliable systems can develop from information security management through. So that it's the more we can just to derive from as here with many benefits. If we go ahead with like this, the systems amalgamate all together can have a more fruitful systems to in our hand, in customer's hand. Then the customer satisfaction is more fast, more higher than the previously. So that's why the main object of this, the latest and the new approaches of the security, reflexive security phenomena. So there are 6 pillars of DevOps automation. Very important this one, because these pillars are highly impact of the development life cycles and the application process. So each one individually given a high impact for the whole the process. If one is collapsed, that's the entire systems will be collapsed. We can't expect that the proper system what that we the design. So that's why, so these pillars are the principles or we need to obey. The collective responsibilities, training and process integrations, paradigmatic implementations, bridging compliance and development, automations, measures, monitor, report, and actions. Each and every sections having several subdivided sections. So further, if we all go ahead with this theoretically plan, so that is the process, that is the source that we are planning in the DevSecOps. And all each and every segments, that the main characteristics is agility and the security and the automation. That's all parts are the automation. Those are the main elements that we can identify on all the segments. Just in brief, like this graph is depicted that whole the area it's compressed, that how it works in the DevSecOps systems, DevSecOps, the life cycles, development life cycles, secure life cycles. So you can see that it's all the main segment start stages are there, or the secure design and architectures. This is from the beginning that we need to design the system. From the beginning that, of course, like our main concentrates on to the secure design. That means from the beginning that we need to decide which part should be have a security or a secure coding. The next one is secure for your infrastructure facilities, right? So from that that of course like again threat modeling and baseline and assess security control, right? As a security control, those are the main concentrations about the security, considering the secure design and architecture. The next point is secure coding. That's the second part. Once you're designing the systems, that you need to start to implementations of the secure coding. The secure coding sections is develop pull colon or commit and continuous developer codes. Then at this moment, but from the security points of view, that we need to concentrate especially for the ST, static application security testing, in this period. And of course like software composition analysis to identify pull colon or commit to identify if there is any the vulnerables on particular secure coding segment, until that is the clear, not moving forward to the next steps. That is the characteristics of these development cycles. That is why our expectations on here. And also, but the automated applications are running on particularly for to find out those sort of issues or a sort of vulnerabilities on particularly in particular area. And continuous and source code review, continuously review that the source code is not going to be stopped. So, and developer codes, that plays that phase that we integrate again the static or IDE plugins, especially for the hardware parts, also be having sort of a secure coding checking. So source code repo, and those are the steps, those are the security measures is going to be measuring for the secure coding segments while this one. Once we have satisfied or in this part of the section, so then move forward to the next sections. Continuous build, integrations and testing. That part of course like build and integrate, package and stage and test. So security point of view, we are the approach is that the statics SAST and SCA, software compositions analysis, and of course continuous and image scan package as if there is a kinds of a, and dynamic application security testing, fusing IST, integrating application security testing. So once we have completed those all the testing, so we'll move forward to the next steps. That is the the life cycles procedure, the continuous delivery and deployment. Now this is very important, the phase, because this is directly going to be a deployment, this application. So hopefully, but it will uh, test if it will run on the customer end. So and publish to artifacts and image repository. So continuous in infrastructure and infrastructure. So systems constraints and network vulnerabilities scan. So there are many scan procedures are going on then during this phase. Image scans, site and artifacts and imaging repository. The security part is covered from this stage, but this is also continuously happening. The ultimately we move forward to the next steps is runtime, defense and monitoring. This is continuous already, right? So we'll see that the whole the parts continuous unless the designing all the other parts are continuous happening. So and of course like it's the agility and the security and the continuous and the monitoring, that of course like its characteristics from this architecture as I mentioned since early. So from this last stage runtime, defense and monitoring part, so it's already been continuous systems, containers and network vulnerabilities monitoring, RASP, runtime application self protections, application testing, rules and penetration testing, continuously penetration testing. So those are the testing, the segments, the methodologies, right, applicable in this the management systems. So ultimately that so we can get that the maximum benefits of this cycle and ultimately produce that the product what we expected, what we have to as agility and security and continuous monitoring capabilities. So DevOps, CSA DevOps, software delivery pipeline, that is a procedure, the being from beginning to end. So every piece of software goes through the stages of connections: design, deploy, build and test prior to the development in production environment. In this modern software delivery pipelines, tools are heavily automated to guard stage checkpoints. At every pipeline stage, automated checks and performs in order to prevent quality issues slipping into the next stage. So as I said, like mentioned earlier, this whole the procedures are in place as a principles, as rules and regulations to keep them as a standards to be developed in a good application. So that's why the DevSecOps, the software delivery pipelines is perfect, the methodologies to be applied. And multiple processes are involved within the software delivery pipelines. It is not only one process, that there are multiple processes. It's an amalgamate of the multiple processes to ultimately to become a reality, the good development process. So that's why I said like, so there are plenty of tools, and as I show that it's earlier, using to keep continuous developments. The tools used by the development and operations, they includes source controls build, continuous integrations, containerizations, configurations, management, orchestrations, and monitoring. These are, and again, very important characteristics I mentioned at last, that orchestrations, because it is a backup system. It's kinds of a backup. If it's orchestrations, is simultaneously running multiple the containers or multiple copies of the same image in a system, in a virtual system. So what happens ultimately if the one system is collapsed or failure we identified, as if we can't exactly identify that was happened, because why, the replacement is coming very soon as a copy of another copy. So therefore orchestrations is the major technical the replacement that recently happened for the software development, the pipelines or development life cycles. And six pillars, the supporting, reflexing, just to brief on that, like again the pillars, what's that I mentioned earlier, responsible collectively, security leaderships play sharpening roles for information, that the main roles of the security within an organization. So responsibility collectively, not only one place, not only the operations, not only the developments, not only the security engineers, no, this is the collective responsibilities that should be understand that all together. If there is any the processed failures or some sort of implementation, should be go ahead with that the particular team and to discuss, because otherwise it's not the individual factor. So everyone should be collective factors and collective all together merge the systems and will proceed. So that's why responsible collectively. And paradigmatic security should be provides the values, not hindrance for every security initiates or adapted security controls. A cost benefits should be prepared, demonstrating the values of security, which is important because it's a cost, it's a value. You have lost. If something goes wrong, it's a loss. Loss means millions of the money, millions of assets. So everywhere, everyone's efforts. So therefore, it could be very understandable to be dedications on particularly each and every segments. How that the values of the segments, how that the values of the particular the coding principles or whatever, and align and bridge the organization's risks is a very important factor to requirements. So mainly we expected that to be the minimize the risks of the assets by increasing the security process. So automate. The automate is most very reliable for users and as well as developers, and give some break for the developers or the team. If the applications everything is automated, it's running on process optimizing, then we can get the optimizations, efficiency, everything. Measures and improvement, measures and improve. So performance that cannot be measured, however, can improve. Without measurements, there is no understandable evidence. So therefore, each and every time trying to make sure that's the validity of that the whatever that is the delivered. So measurable is very important to improvement of the systems. Collaborate and integrate. Security can only be achieved through collaborations, not confrontation. A security aware and collaborates culture is necessary for everyone to feel comfortable reporting the potential anomalies. So collaborates is the important factor, pillar of this one. Then security improve over traditional software life cycles. That of course, like we need what the traditional way is happening, that we need to have a more improvements in software life cycles. Meantime to production. So the average times it takes from to the development process, it should be a very little. So mean times to the development, that is improvements of average lead times, how long it takes to for a few requirements to be delivered and deployed. Considering the small segment part, that was how long it will take. So that's depend on that your total the agility of the software development speeds. That's of course like there should be the methodologies, tools and procedures in proper principles. So then the development speeds is faster and faster than the traditional methods. Development frequencies, the number of things that it's at simultaneously running, that is also given high impact. Production failure rates. However, systems in the productions may fail. That of course obvious, but the rates, how much is maybe depend. That's a depend on the expertise those who are involving, and meantime to recovery. If something goes wrong, how long it will take to the recovery system. That is the characteristics in high standards it shows. In addition, DevOps practices enables fully automated risks characterizations, monitoring, and mitigation across the application lifecycle. So, if possible, to have is automated and keep the monitoring, keep on your eyes to mitigate all the process in the life cycles, to mitigate the issues. Software updates and patches at the piece that allows to addressing of security vulnerabilities and code weaknesses. Oh, this should be monitoring and should be upgrade continuously as a principle. Otherwise, you could have many vulnerable the systems and some weakness of the coordinates. To keep it strong, it must. Here are the principles of architecture for any architecture. Those who have developed for any applications, even though this is a Twitter applications or some sort of the Facebook applications or Uber or whatever, that these principles are very important, very key to keep as eye on this DevSecOps architecture. So that's important characteristics. Again, remove bottlenecks. The bottlenecks should be removed somewhere. It's happen. Otherwise, that all it's already being affected to all the entire systems. And the manual actions. No more manual actions. These proceeds in this DevSecOps, it should be automated, autopilot. Then only we can expect that the maximum benefits from that. Automate as much of the development and deployment activities as possible. Even though the deployments also the automatic and developments also the automated, it's a high values is given. Adapted common tools from planning requirements and deployments. The very adapted to common tools, because these tools should be tested, well recommended and used by the developers and know any issues and errors. So we have courage or to continues without any loopholes on these tools. So that is why the tools are important. The use as a principles here. Leverage agile software principles and favor small incremental frequency updates to our large, more sporadic releases. The agile software principles that to be adapted, because we need to have the speed up the process. So what the to speed up the process, that we need to cut off that the segments or some process to which are slow the systems, slow down the systems. So then we need to have add the patches, we need to close the patches, we need to cover up updates. So then only we can go ahead with that agile software, the principles that we need to speed up. Security risks of the underlying the security risk. However, there is a infrastructure. Due to the infrastructure, we have the security risks. So we need to have good infrastructure must be developed to eliminate the security risks. We need to minimize and mitigate the security risks of the systems with good practices, good principles, software applications or whatever that the risks, if we need to minimize it. Apply the cross functional skill sets of development, cybersecurity and operations throughout the software life cycles. It is a to develop in the process the good process, the good operation practices to hold the process to keep up in a high standards, embracing a continuous monitoring approach in parallel. It is a main factor to continuous monitoring, not only one place, not only one times, not only the redesigning, not only the codings, developments, no, each and every time, 24/7, it should be a monitoring autopilot running to see whether that if there is any sort of vulnerabilities, any sort of issues, any sort of weaknesses or upgrades required, and get some the messages of that monitoring automated team. So have like to see whether that evaluations, loggings, the continuous logging files, so then it may have peaceful systems we can develop with a good architecture. So somehow adds this one deploying immutable infrastructure such as containers. Huge. It changes that this millennium, this exactly for these last decades, in a virtual environment. It says the virtual environment is the given high huge impact of that now security and the agility both together. So the container is another fact that we uh, got it for the development process and applied it for being expecting some security and as well as the backend procedures or agility to deploy. So there are such and such advantages and disadvantages. On this particularly mainly advantages are given this uh, the container concepts of the virtualization. So that's major principles. Now we need to not the traditional methods to apply. We need to apply its new latest technologies. The Twitter is the main application that I'm going to be just to brief on that particularly in this my presentation today, to what sort of a DevOps architecture is being used by them to develop that the application. Sometimes when you think about that, Twitter is that it's the major apps or applications is popular among the world. Many professionals, politicians, artists, or so different, and as well as general users. Therefore, this is quite interesting. The people, how and quite registered and to use it's every day like millions of people in this world's users. So therefore that my interesting goes on to be check whether that how the systems improvement on this Twitter according to that the Twitter architecture according to the point of view of DevOps. Twitter online micro blogging services to distributing short messages systems. We started for like it's having some short message systems from through the mobile. This is exactly the mobile app. This is because the mobile app is quite interesting and developing part of the industry. So being last decades, the Twitter incorporates aspects of the social networking. It says as websites such as MySpace and the Facebook same. However, the Twitter is the most the popular, the messaging communication system at this moment. This is built of actually Ruby, the language, on Rails, a specified web application framework. It's a web application framework. Then therefore the security is main concern on this because it is already running. This is we can't say that an application sometimes is kind of an API. Look like it's the API, it's a Ruby programming languages to use to develop this one. So at that time when that was developing, the starting the design the systems by more than 10 years before, this is quite a challenge. Like its platform is a Java based platform, and when you go ahead with that on particularly this the Twitter is built up with the architecture comparatively this overview, like I can just to say, because this is JavaScript application and small simple, right? It's Node.js server. So at that time they are not much concentrate on particularly for the security, not actually it's not the DevSecOps systems, because they just to have like some idea to have just a general communications with the SMS messages. That's what they initially ultimately, but it's that says here that once loaded into the browser, the app requests data directly from the Twitter API. Once your app is there in your machines, that API is to deal with the other parties. So that's general scenario of this application. So Then this is the performance based development application, because the users, step by step, with users, millions of users are connecting with these applications later on. So then they required to have some sort of other important the the elements to be implemented, like such as that availability. It's maybe a first priority for this one, because that is Twitter leads is a network resilient to each every person have a present. So but availability is a very important factor. Then availability, if you need that, we need to concern about the security. By if something happen in the security systems, the availability is maybe having some sort of a challenge, right? So and the progress loading, the progressive loading is that continuous, how much is time taking to link with the telecommunications, because this most of depend on that the telecommunication systems which is connected with the mobile phone to upload the apps. Then it's not should be a very high rate. The Twitter lights is interactive in under 5 seconds over 3G or most devices. Those are the considerable characteristics that we need to know if you're implementing the proper systems, or the continuous process. The most of the world is using 2G or 3G, but it's depend on that the country where that you are living, the user is logging. But it's not only the 4G, sometimes 5G is available. They don't have much issues, but some are still being with the 2G network. So when you're connecting with those, then that there may be some circumstances is happening, so or whatsoever, but that the system should be compatible with each and every the segments, to while you're considering that your design stage, and as well as that your the security framework. And also, but the rendering, the expensive rendering work breaks up and the rendering work. So although we have taken care to optimize the rendering of our components, and tweets is the complex composites components and rendering initiatives, list of the tweets required additional performance considerations. So it's maybe sort of that it by itself that they are given the solution for that one. Data usage also, but it's the huge contains huge linking. Those are the correct design systems and iterations speeds. So and looking ahead, so many of that characteristics that they all might think once they are considering the Twitter, the implementations process of the framework, and having some the details on that of the how that implemented the tutor. It's already mentioned in that Wikipedia pages that some details actually directly they are not provide us exactly what that they are deciding, and the secrets of the development process as the security perspectives. So that's why we need to find out that some of the details from that Wikipedia or social media that people are sharing with us, because that of course like they are the hidden by for the users. So most probably if you're going through that particularly for the application base. So we'll go ahead with moving for this one. So and the process of that the Twitter that they applied tool pipelines as the scenario is as like this, that always that it's in a same as that our DevSecOps principles. So the applications already being in a continuous way that it's running. That is why if there is implementations, because this system is now not for being for a long time, it's maybe running on system. So then what we have to do is like some implementations, some sort of a changes have to be applied, so then it will maybe continuously upgrading. So that's why this monitoring system is continuously running on the system, so without any doubt, so 24/7. So then if there is any sort of a vulnerabilities, if you're understood, if there is, then they will sort out the systems. That of course, like it's a Twitter system is running on, particularly the whole in the process as to such is the Deus Ex Ops is already implemented. And and of course, like it's their architecture is given like some the way of it's showing here. The API is common API is already being on top for that one is linked with the uh, ingester or fan out, like it's they divided into different exactly, but most probably it's different containers and different boxes. So but once the service is like it is like having with the while providing the service, it's maybe according to the requirements of the customer, so that it will provide separately for the users. So by the way, like whole um, the cache and the memories are in separate segments, the separate containers are including the services are required, it will give as a one service. So that's the flat platforms that we can just to identify on the Twitter there. For however, but I'm just going to briefly discuss about that the conceptual model. So what sort of a conceptual models is that important to develop the software and deploy the software to keep. So not only the tutor or whatever that it's sometimes maybe tutor or a Facebook or whoever that it's using, that they should be to use it, or they adapted to the conceptual model. That conceptual models is look like this, but here Deus Ex Ops ecosystem, right? Software factory and pipelines applications. That is the four area. It's connected with the environment. The environment directly connected with production environment, production and pre-production, test environment, development environment. All together, those the environment is connected that each four areas, and there are particular separate segments: CI/CD, orchestrator, and DCAR, that user levels, and the tools and the um, Sidecar container security stack. So those are the conceptual model that is implemented to show that the connectivity, show that each and every connectivity, this all the one and individual segments we can talk more and more exactly. So then the Deus Ex Ops software life cycles is being look like finally it's like this. So because it is already security is the integration with integrations with ops and devs, developments and operations. The security is integrations, but security is not only in one place, it's everywhere. Security is spread into the everywhere. This is the wonderful the diagrams shows to how to show that this is a continuations of the process of Deus Ex Ops and the architecture, architectural security to perspectives. So the secure coding, threat model, and statistics and static secure coding methodologies, everything is there here in this life cycles. And there are some pillars of four main pillars of the Deus Ex Ops: the organization, process, technology, and governance. Those are the main four pillars that we are considering on the Deus Ex Ops. The each and pillars are, it's given a huge impact to whole the process, and if to need each and every pillars are divided into separate segments to how that it will be contributed to the run of the DOP system technologies systems. So the main part, and this is operation part, and as well as operations governance bodies is also be involving for this one to be continuous, this one. And the technology part is separately, it's there. Not only that one, it's that's why the process part is there, organization, governance, everything. It is it is actually uh, amalgamate of that each and every segments together to run the DevSecOps systems. So again, that therefore these pipelines very important: continuous integration, continuous delivery, continuous deployment, continuous operations, and finally continuous monitoring. It's the major characteristics of that we already been discussed from the beginning to end. The code, security as a code, again another new latest concepts is the security as a code. Because why? So the earlier that if was like the codes are sometimes maybe the not the part of the security. The code is developed by themselves by the developers or the programmers with much concentrating about their perspectives mainly for the designing, even though that the designing to objectives is to completed the applications, the process of the applications, the user requirements. No, then now it's a security as a code, taking the same approach as IAC security teams program security pipelines directly into the configurations codes, as well as the implementation security compliance checking and auditing as codes, which are referred as security as codes. So that's why that this one, as I mentioned, that the develops the ecosystems, DevSecOps ecosystems. It's also major considerations on particularly for this one here, the DevOps ecosystems in this first part. So the DevOps ecosystem is the collections of the tools and the process workflows created and executed on the tools to support all the activities throughout the full DevSecOps lifecycle. The DevSecOps ecosystems is composed of the three subsystems: planning, software factory, and production operations, as I show in the diagrams. The ecosystems is again can divide as like this. So it's a mission critical application team. DevSecOps, all three people are involving on this ecosystem to develop planning tools, requirements and project plan, right? Planning and software factory is there to build up the software, testing, release, right? So the operations part is in the other side. Deployment is operations, so monitoring tools. Production environment is already there, monitor operations, and also it should be at some DoD centralized artifacts repositories. The databases are also involving DoD common security services, enterprise services, enterprise AO, enterprises. So then this whole the affords together this the DevSecOps ecosystems will be created. The DevOps ecosystems interact with external and enterprises services to get all dependencies support, and with enterprise and local AO to gain operations authorizations. DevOps administration teams is responsible for administrating the ecosystem tools and automated the processed workflows. So finally, about this one, software factory, it mentions the software factory contains multiple pipelines that which are equipped with set of tools, process, workflow, scripts, and environment tool products, set of deployable artifacts with minimal human interactions. The software factory, doing the huge part of this business. Automated activities are given, automated applications, automated software, so testing methodologies are given huge impact for this one to run on this. And a software factory must be a design for multi tenancy and automated software production, so multi projects. A DoD, Defense of Defense in USA, organizations many needs to multiple pipelines for different types of software systems such as web applications and embedded systems. So here is that the software factory look like, how that your application, your development process, any applications, the Twitter or whatever, that if you're intended to develop in the precisely the applications that we need to have the intended like such um, designs according to DevSecOps framework. So code scripts IDE, that is a hardware part in, and also involvement of the code repo, local artifacts, and development environment is the pipeline 1. Pipeline 2 is an development environment and testing environment. It's coming to the next step is a testing, develop, and the testing. This should be a test in pipeline 1, 2, 3. That is process in up process, down process, and the bottom. Integrations, pre-environment, release package, and release artifacts. So that's why CI here it's in the middle and the CD is coming to the end. Alright, CI is always each and every points that we need to this one. So however, that's general. We see that this the procedures of the running on the software factory on this architecture. The external and internal both systems that should be like as I mentioned. Then the DevOps ecosystems itself and the program applications depends on some DoD enterprises services to acquire the necessary baseline tools, applications, dependency, security services, and the operate. External system. DoD centralized artifacts repositories holds that hardened virtual machine image and hardened OCI compliance container images of DevSecOps tools, container security tools, and common program platforms components. It's just to have like internal and external teams systems amalgamate ultimately to the systems implementation process. And yeah, here also that's mentioned at the same points that in especially for the cyber security maybe like considering so performing on these external systems the further it's mentioned here that security models of the system. It's a security model of a system, that how that the security models should be with the in a delivery level or development levels. So most probably each and a very important this one, because if you think about like it's in for example A6 C6 means that at this point A6 right, so A6 is a report data, right, and here it's assets and threat agents and controls and are already being here. So then if any circumstances like if go ahead with that A2, A3 and A4, so it is defected through the through browsers, sometimes APIs, sometimes maybe like it's in a development stage in a JavaScript codes. That's why it's mentioned. Then at that time, so need to have some sort of the actions or precautions, or we need to have some sort of the methodologies to be overcome. This is very important because we need to identify that what sort of the threatened activities we can expect it from the segments that we each and every area where that we deploying. So while deploying, and which area that it's maybe having high risk area. So risk is designing from the designing stage that this model should be created, then that the developers should be the intended to is particularly this area on particular matters. For example, like sometimes maybe some external and some internal. So both that it's here DMZ, the demilitarization zones, that if they're here. A3 is the A3 is important for this one. Session tickets it's creating. Then if that having some sort of the vulnerabilities or some sort of the issues on these session tickets that we need to consider in this area. So that's why this is most the important and the diagram that I show on this presentation. So threat modeling. So threat, like it's that is the outsides or inside or internal or outside external the activities that we given for us to uh, having a compromisation. So that's why this threats is there. Then how the threat modeling is the structured process with these objectives, identifies security requirements and pinpoints security threats and potential vulnerabilities, is quantify threats and vulnerability criticality and priority and remediations methods. Threats modeling methods create the artifacts. So that's all. That's the factors that it's maybe depend on that the threat modeling concepts and abstractions of the systems, profiles, potentials, attackers. Those details also don't need to know, like while you're designing the systems. Planning tools and activities, given the huge impacts, there is no any doubt. The planning tool supports software development planning, which includes configuration management planning, like sort of a things that it's maybe in a pipeline. So planning tools, team collaboration systems, issues tracking systems, assisting inventory management systems, configuration management systems. Those are the tools that we need to concentrate for the development DevSecOps tools as activities. For the important part is the tool must be the minimal viable product. The ecosystems, while the minimum viable products, the MVP, as thresholds, it's the thresholds of its tools in objectives to be reached as the ecosystem measures. That is the measurements, that is the ecosystem measures. Then there are some tools to measure that this MVP. Those tools are under categories of the MVP. It's maybe very contributed to us to the while developing as a good practice of to measure this one. Software factory tools and architecture, CI/CD orchestrations. We already discussed about that, and develop, build, test, release, and deliver. And from the operation points of view, deploy, virtual machine deployments, container deployments, operate, and monitor. So those factors that it's already highlighted on my the presentations and earlier parts of that one. Here this is enterprise DevSecOps container service architecture. The container size wise, the architecture is mentioned here, like in the DevSecOps. So this architecture is also may having some sort of impact. So it's easy to understand, not much too complicated. So then this is some sort of a the conceptual virtual methodology of containers. The container, the ecosystems having a separate the containers, like some segments as divided into a separate. So the centralized repository systems also the mentions that the others are interrelated, each and every one. Overall, that I can just to sum up this whole the process, that if from the perspectives of the today's presentation is mainly for the architecture, that good architecture if you have as DevSecOps, that your applications is the Twitter or Facebook or so at Twitter or Facebook or Instagram or Uber, so whatever, that then can minimize the mitigations of the security risks. And of course, like agility is very high, then the customer satisfaction is more and more. So that is the high of ultimate expectations to become a reality of that our development life cycles is what the mainly for the security concerns. And continuations is another factor. The continuations, it's the system is continuously monitoring, continuously developing, continuously operating. So if you are doing the continuously sort of the activities, then what happened, the ultimate or reality is to become the the highly valuable the applications or live applications or software or coding source we can expect it. But the vulnerabilities, it's maybe a common, it is not the unexpected scenario. But the vulnerability is a common, because it may, and also we need to understand that it's the existing vulnerabilities also there is. And this the most of developers are sometimes, maybe if you're not in a proper manner when you're developing the systems, what happens is that they are already continuously doing the existing vulnerabilities as well. So existing vulnerabilities means vulnerability which are already being mentioned early and identified and stored already being in an industry, so in our network. So then we need to understand that, avoid that the existing vulnerabilities and reduce zero-day vulnerability. We can't believe that whatever that it's coming tomorrow. So that's why we need to have a continuous security, continuous protections from our systems through the good practices. The good practice is what the good the structure is what that the structure of the DevOps, DevSecOps, the development, security, and operations to systems that to intended to that your applications, your running process. So about that the architecture of cybersecurity, the requirements, like mainly because the cybersecurity, when you're considering that, we can talk about it more, because the containerized architectural factor is given a huge impact to the this high security implementations of the development life cycle. So that is, of course, like the recently added these concepts, because after Google, they found that this container concepts is adapted by themselves with a huge impact. So then after that, they introduced into the world that this is you can use it for your development process as well. So then now it is currently that have opportunity to it is to amalgamate with the DevOps, the DevSecOps to be implemented that your development process. So fortunately, so then that is giving the huge impact for the this one. And the applications and the software factory and the container orchestrations and the hosting environments, the virtual environment, the cloud, wherever. So those are the infrastructure facilities, and given and with amalgamate with this DevOps systems rather. So again, further, like in here that it's already mentioned, the cybersecurity requirements on the part of this on this here cybersecurity, the hardened containers produced by the factory should meet the related cybersecurity requirements, which includes it is standardized NIST standardized special publication practices are there to be applied to using these important guidelines to carry on. Container orchestrations is in order to support containerized software factory tools that underlining container orchestrations must use the CNFS certificate Kubernetes and support OCI complaint containers. The Kubernetes are the very latest applications, very latest methodologies, the practicing good practice to have a containerized implementation. So it is given a huge security aspects for your source code, and as well as having some the backup plan, proper backup plan, like the orchestrations is in this Kubernetes. So that's why here that it's mentioned that is different phases software factory, how these different phases are already being protected with this one here: plan, design, initiatives, and verify. It's in under plan, right? Under plan. So deploy, build, test, phase, and deliver. That is, of course, like operations and monitor. It's as the same the process of the DevSecOps general, the procedure. It's maybe amalgamate, it's maybe implementing. And also, but another sidecar container security stack. It's the latest, it's a newest service that is enabled with the Deus Ex and container based Kubernetes runtime environment in this sidecar container security stack. This security stack enables correlated and centralized logs container security, east-west traffic management, zero trust model, while it's role-based access controls and continuous monitoring, signature-based continuous scanning. Those sort of and sidecar container security stacks is recently added to these systems to get more benefits than the earlier systems. That it is, of course, like it's a application is there, the sidecar container is separately there. If there is need to some requirements, so you can have with particular container to go ahead with that the particular container and get the services to the upload it to your particular service. That's the this is added to the additional container for that entire the services or Kubernetes. So that is the shared base separate application container. So that's facilities, that features is already been implemented in the systems to be used recently. And also, but the logging and the logs part is also maybe having a huge impact to the continuations monitoring. That of course, like it's already being provided in this DevSecOps framework. So here is that how the logs are coming, that each and every hardware part and systems are logging here, and if the logging is how to create it, and it's how it's circularization. So to each is incidents, that if something goes wrong, that it will have some the results, and it's again come back to be again like this is very important to run on that monitoring part. It's imperfectly and the rectifying the issues and on the process, the live running process. This is very huge impact for this analyzing process. Ultimately, this is operation. Most probably, this is not the developers. It's the operation team should be handle these sort of diagrams, application platforms. It's very important for them to keep alive, keep on eyes that one continuous monitoring. Continuous monitoring is an extension through continuous operations. It continuously investors all system components, monitors and performance, security, all the components and log applications and systems. If any failure, illustrates the simplified simple process monitoring, logging and log analysis and altering, which also applies to deployments to non-containerized environments. So that of course, like this monitoring is not need to be defined. It's already should be the automated monitoring systems continuously running to keep the proper the systems. There are some the remember that the earlier stages also we just discussed about that the DevSecOps that characteristics, vulnerability, outdated third-party libraries, licensing issues, some sort of issues, and sensitive data leakage, vulnerability to base images, and Kubernetes misconfigurations. Those are some sort of issues can be possible. We hear that I already mentioned about the DevSecOps systems, how it works and their importances and the practices. You know that the applications where that it's everywhere, it's supporting with the DevSecOps to keep coordinations and keep continuations, right? So that the Kubernetes like such and Docker, some sort of applications are, it's maybe a huge impact, and Jenkins to the integrations to both operations and developments for intermediate. So and huge impact is given. Some tools that are important tools that it's maybe using for the DevSecOps. It's maybe given like that some sort of the brief on the virtualizations at this moment, not necessary to be highlighted that those areas on whatever that how the virtualization is maybe implementing and how it works. But to have for the future references, I just keep that those details about that, how the containers are working, how that the hypervisor is using as a virtual environment. Docker engine is how to use it for the future uh, reference that it's already mentioned here, that the monolithic and the microservices that has been applied in the containers or Kubernetes uh, before they implement in the applications, that it may be mentioning on that further, the Kubernetes containers, that how it works, and the orchestrations methodologies that it how can impact onto the whole the process, that it's already been mentioned on this. Because today's lessons is mainly my part has been like concentrated particularly for the not only this one, the particularly for the particularly how that the architectural the format is important to develop the applications, such as that I just to get the mention about the Twitter and that keep that updating, keep that there the troubleshooting continuously using that the applications in proper as we expected here. So that's why this I expected to here, but I'm not going to further on particularly the brief on that other areas, but we already discussed on the many times particularly for those areas. However, but in today's sessions that I just expected to mainly highlighted on these areas, and as well as the agility and the security, to keep that the continuous monitoring on that the proper architecture like Twitter or Facebook or Uber or whatever applications that their implementations, the stages to keep run on with high security, and as well as that the continuations. Thank you very much on particularly for this given these opportunities, and I learned a lot of things on based on this about the secure architecture. Thank you very much.